This is a quick introduction to CMORising ACCESS output for the CMIP7 FastTrack, using ACCESS-MOPPy on NCI Gadi. In about 10 minutes, we'll go from raw model output to CMORised NetCDF files. First, what CMORisation actually is. Raw ACCESS output is written the way the model wants to write it. Its own variable names, its own units, its own file layout. CMORisation rewrites that into the common CMIP standard. Standard names, standard units, standard metadata, standard structure. That's what lets any model be compared with any other. And it's what lets evaluation tools, like ESM-Valtool and EYE-LAM, read your output without knowing anything about ACCESS. ACCESS-MOPPy is the ACCESS CMORiser. You can drive it from a notebook, from the command line, or as a batch service on Gadi. It supports CMIP6, CMIP6 Plus and CMIP7. It's already installed in the ACCESS-3 environment, and it's fast and cheap in both wall time and service units. Every production run is the same 4 steps, whatever project you're CMORising for. Load the ACCESS-3 environment. Write a batch config file, which says which variables and where the data is. Run moppy-cmorise, which submits 1 PBS job per variable. Then run moppy-tui to watch it. That's the whole workflow. And the rest of this video is those 4 steps in detail. Before you start, you need 3 things. An NCI account, with membership of XP65, which is where the module lives, and of the project that owns the model archive you want to read, which is often P73, a scratch directory you can write to, and the path to the run you want to CMORise, which is normally a PyU archive route on GData. Step 1. Load the environment. 2 module commands. That gives you moppy-cmorise, moppy-tui, and the rest of the command line tools. To check it worked, run moppy example config, which prints a fully commented example config. One thing to know before you go further: the first time ACCESS-MOPPy runs, it asks for your name, email, organization and ORCID, and stores them in .moppy, user.yaml. Those are written into every output file as provenance metadata. Answer the prompts once on a login node before you submit a batch. Otherwise, a queued job will sit there, waiting for an answer that never comes. Step 2. Write a batch config. A batch config is a YAML file that says what to CMORise, where the input is, and what PBS resources each job gets. This is a complete, working, minimal example. 1 variable access ESM16 CMIP7. It's 4 blocks and we'll take them one at a time. Block 1. What to CMORise. 1 PBS job is submitted, per entry in this list. Block 2. Who the data belongs to. The CMIP version, the experiment, the model, the variant label and the activity. This goes into the file metadata and into the file names themselves. Block 3. Where the raw model output is and where the output should go. Point input folder at the archive route. Moppy finds the files itself. And block 4. The PBS resources each job gets and how to set up its environment. Note worker init at the bottom. Each worker job is a fresh shell, so it has to load the module again for itself. And that's the whole structure. Everything else in the configuration reference is optional tuning, on top of these 4 blocks. 2 things worth knowing straight away. First, you do not list input files. Set input folder to the archive route, and Moppy uses the model's built-in file discovery rules to find the right native files for each variable. Only reach for file patterns if your run has an unusual layout. Second, start small. Run 1 to 5 variables and check the output before you submit a list of 200. Failures are much easier to read when there are 3 jobs than when there are 300. To keep a test run short, set start year and end year to the same year. Step 3. Run it. From a Gadi login node. Moppy-cmorise, then your config file. That's the whole command. Here's what that looks like. The command records every variable in a tracker database, submits a single PBS monitor job and exits. The monitor job is the thing that then submits 1 worker job per variable and retries any that fail. Note what it prints: where the database went, the monitor job ID and how many variables it's watching. Because the monitor and not your shell owns the batch, you can log out straight away. A dropped SSH connection will not stop the run. Step 4. Check the status. The tracker database is written to cmortasks.db inside your output folder. Point the terminal dashboard at it with moppy-tui. It refreshes live, and shows each variable as pending, running, completed, or failed, with error messages for the failures. Here's that same 3-variable batch a few minutes in. 1 variable done, 1 running, 1 still queued. The progress bar at the top tracks the batch as a whole. And here it is, finished. The batch is done when the progress bar reaches 100%, and nothing is left running or pending. Press Q to quit the dashboard. A few useful variations. Filter by status, to see only what went wrong or what's still going. Use -- once, for a single snapshot, which is good for a quick check or a cron job. And moppy batch report gives you a full JSON report of the batch, including the PBS logs for any failed tasks. Step 5. Look at the output. Your CMORised NetCDF files are written under Output folder. Per variable PBS logs.out and .er land in a logs directory underneath it. 1 directory per variable. That's the first place to look when a job fails. And to check a file against the CMIP7 output QC rules, run moppy-qc on it. So that's the general workflow. Now, what makes a run specifically CMIP7 FastTrack? 3 things. Set CMIP version to CMIP7, set source ID to ACCESS-MOPPy, and use CMIP7 branded variable names instead of the CMIP6 table.variable form. Note that grid label is deliberately left out. For CMIP7, moppy resolves it per variable from the model mapping. Branded names are the biggest visible change. CMIP6 gave you amon.tas. CMIP7 gives you this. It looks like a lot, but it's only 5 fields, and it spells out what used to be implicit. Realms, atmosphere, variables, tas. Then the cell methods which say, time mean at 2 meter height, on the horizontal XY grid unmasked. Then the frequency, monthly. And then the domains, global. You don't need to memorize these. The maintained baseline config lists them all, and you copy the lines you want out of it. One more CMIP7 block worth calling out, parent info. It describes what your run branched from, and it's required for publication. Copy the shape of it from the quick start, but do set branch time in parent to the real branch day for your run, rather than leaving it at 0. Once a small run works, don't write the full variable list by hand. Start from the maintained baseline configuration that ships with the package. Copy it out and edit it. It contains the whole FastTrack baseline variable list, with unmapped variables commented out and marked, plus per variable PBS resource overrides. Those overrides matter, because a 3-dimensional pressure level field, or a sub-daily field, needs considerably more memory and wall time than a 2-dimensional monthly one. There are bundled starting points for the higher frequencies too. Daily, 3-hourly, 6-hourly and hourly precipitation, each set up as a 1-year resource test. Run the one you need for a single year first, see what it actually costs and then scale up. That's the quick start. Where to go next? The FastTrack baseline how-to is the full contribution guide, including how to report mapping gaps and failures. The batch processing guide covers resource tuning and error recovery, and the configuration reference documents every single key. All the links are in the description below. If you hit something that doesn't work, or a variable that isn't mapped yet, please open an issue on the repository. That feedback is genuinely how the baseline gets finished. Thanks for watching. One note on how this video was made. The narration voice is synthetic, generated with an open-source speech model, and the script was drafted with an NRI assistant from the ACCESS-MOPPy documentation.